Well, welcome back. In this lesson, we are going to be talking about polygons in the coordinate plane, and we're going to work on classifying those using a lot of what we've learned from algebra. So this first slide has some formulas that we've used in the past that will be helping us, and the distance formula will help us figure out whether or not sides or diagonals are congruent. The midpoint formula not only will help us find the midpoints of sides, it will help us decide whether or not diagonals are bisecting each other. And the slope formula will help us determine whether or not sides and diagonals are parallel or perpendicular. So in our first example, we want to know whether triangle ABC is scalene, isosceles, or equilateral. A scalene triangle, if you remember, has all three sides different lengths. An isosceles triangle has two sides that are congruent. And an equilateral triangle has all sides congruent. So the vertices of our triangle are given, and we need to use the distance formula to find the length of each of those sides of the triangle. So first of all, side AB, using our distance formula, turns out to have a side length of 5. Side BC also has a length of 5, and side CA has a length of 5 square roots of 2. So, since we had two sides that were congruent in length, AB and BC had side length 5, therefore it's an isosceles triangle. Here's one for you to try. I've given you triangle DEF. Here are the coordinates of its vertices, and I want you to determine whether it's scalene, isosceles, or equilateral. Go ahead and pause the video. I'll give you the answers when you come back. Alright, I hope you had a chance to try that on your own. Using the distance formula, DE has length square root 17, side EF has a length of square root of 20, and DF you should have gotten a square root of 29 for its length. Therefore, since all three are different, the triangle is scalene. In this problem, we want to determine whether or not parallelogram ABCD is a rhombus. So remember, if it's a rhombus, its diagonals will be perpendicular to each other. So we would need to find the slope of AC, that diagonal, and the slope of BD. If they're opposite reciprocals, or if their product is -1, then it would be a rhombus. So the slope of AC is 5/6. Using our slope formula for BD, we get -3/2, and the product of those two is -15/12, which is not -1. So since the slope is not -1, it's not a rhombus. Alright, here's another problem. We have parallelogram MNPQ with the four vertices given, and I'll draw that in here for you. I want you to determine whether the parallelogram is a rectangle, whether it's a square, and then part C has to do with problem number 1 a few slides back. Determine whether that was a right triangle. Go ahead and pause the video and work on these, and I'll give you the solutions when you come back. Alright, so if this is a rectangle, we just need to show that two sides are perpendicular. Because if we have perpendicular sides, we know the opposite angles of a parallelogram are congruent, and if we can get that one of them's 90, then they're all going to be 90. So, the slope, I picked side MN and NP, and MN has a slope of -3, NP has a slope of 1/3. Those are definitely opposite reciprocals, so it is a rectangle. To show if it's a square, we just now need to show two consecutive sides have the same length. So in this example, it doesn't matter which two sides you choose. I chose sides NP and PQ, and NP has a length of the square root of 10, PQ has a length of square root of 10, and those are equal, so therefore it is a square as well. Lastly, for part C, a couple slides back, we already determined that AB and BC were congruent, so we only need to check to see if they're perpendicular. To check if they're perpendicular, we're going to look at their slopes. The slope of AB is 3/4. The slope of BC is -4/3. And they definitely are opposite reciprocals, so we can say yes, it is a right triangle. In problem 3, we want to classify a quadrilateral. So we have a kite that's given, and we want to know what is the most precise classification of the quadrilateral that's formed by connecting the midpoints of the sides of the kite. Well, first let's find out what those midpoints of the sides of the kite are. Using our midpoint formula, we have these 4 midpoints, and I've labeled those A, B, C, and D. Then we want to go ahead and draw those in. So there is our quadrilateral. Our third step is to classify it. Using our definition of distance on a number line, we're just going to find the distance from A to D and B to C just by counting how many squares there are, and then A to B and D to C this way. Okay? So A, B, and C, D are the same length. B, C, and DA are the same length. So we have those lengths. So it looks like it could be possibly a rectangle, but maybe not. We have to check out a few more things. So the opposite sides are congruent. AD is congruent to BC, and AB is congruent to DC in length. So we know it's at least a parallelogram. But we also know that AB and CD are both vertical, and BC and AD are both horizontal, which means they form 90-degree angles. So since they're right angles, it's definitely a rectangle. Here's your lesson check. There's an isosceles trapezoid with the following 4 vertices. What special quadrilateral is formed by connecting the midpoints of the sides of the isosceles trapezoid? Bring your answer to class. We'll see you next time.